Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of integration and we are continuing our series of questions on JEE Advanced. So today's question we have taken this up from the year 2010 and if I talk about the question which is given to us here, the question tells us that x inside the square bracket is your greatest integer function, and by that I mean here is you have to take an integer value that is less than or equal the value of x. So that is your greatest integer function. Then we have been also told that f is your real valued function which is defined in the limits of -10 to +10, and f of x it's given to us as x minus the greatest integer function of x for f of x being odd. And we have been told this is again 1 plus x inside the square bracket minus x for f of x being. So these are the two functions f of x given. And then we have been also asked to find the value of this entire expression which tells us the limits goes from -10 to +10. F of x cos pi x dx. That entire integral value is multiplied with pi square by 10. So we have to find the value of this entire integral with the product of this expression pi square. So this is the value which we have been asked for. But let's first understand this greatest integer function. Let's put some values of x in f of x and let's understand this, how this f of x or the function behaves here. So let's first understand the greatest integer function. So we know x inside the square bracket is your greatest integer function, which defines that x has the value which is less than or equal to the value of x. So you're just taking an integer value of x which is less than or equal to x. Now if I take some values of x, it will be much more clear to us. So we can have the value, let's say from -2 to the value of x less than 1, from -1 to less than 0, from 0 to 1, from 1 to less than 2, and from 2 to less than 3. And let's take one more value from 3 to less than 4. So we have taken 6 values. Let's analyze them. So whatever is followed in these 6 values will be sufficient for us to conclude that same thing will be followed for the values from -10 to +10. So we'll determine this nature of f of x, that is the function. So if I talk about this value of x, if I'm trying to find the greatest integer value for this function of x, here we know it should be any value of or the integer value that is lesser than or equal to the value of x. So from -2 to value of x less than 1, the integer value which will be there is -2. This tells me that the greatest integer function is even. If I talk about mod, not mod, x inside the square bracket here, it is going from -1 to the values of x less than 0. So greatest integer function is -1, which is mod. Here I understand it is x inside the square bracket turns out 0. Again, even. Here I understand x inside the square bracket turns out 1 because it's going from the integer values of 1 to the value less than 2. So the integer value which is there is 1. So here you are going from x inside the square bracket being 2. So you again get an equal answer. Here you get that greatest integer function is 3. So again, now we know for even functions of f of x, it is given by 1 plus x inside the square bracket minus x. So for the even values, f of x turns out 1 plus minus 2. So 1 minus 2, that is minus 1 and minus x. Again, for this, even if I find it out, f of x turns out 1 plus 0, 1 minus x. Here for f of x, if I find it out, it becomes 1 minus 2, that is minus, oh, sorry, 1 plus 2, 1 plus 2, so 3 minus x. If I find out for odd functions, it is x minus x inside the square bracket. So x, f of x turns out x minus x inside the square bracket is minus 1. So minus of minus 1 turns out plus 1. Here you get f of x minus 1 because 1 is the answer. And here you get x minus 3. So you have this function values now. Now let's try to solve this further. So if I understand the graph here that the function follows, we know that for the values of x, we are just determining the values of y, that is the function. So this x and this x. Now here if I talk about these ideas, I have minus 1, I have minus 2, I have also taken 0, I have taken 1. Let's understand the values here, what the values of f of x turns out. So if I plot this graph for x from minus 2 to 1, we know it is minus 1 minus x. So if I put the extreme value here, that is minus 2, it's going to become minus 1 minus minus 2. So minus 1 plus 2, that makes it 1. So f of x turns out 1. Let's say this is 1. F of x turns out 1 when your integer value becomes minus 2. Then it's going on decreasing. At minus 1, we have f of x as this x plus 1. So minus 1 and plus 1 makes it 0. So we have to get this as 0. Again, at 0, we know f of x becomes this. So 1 minus 0, that is again 1. So you again get the maximum value. If x is 1. Again, here if you put x goes from 1 to the value less than 2. So if I put 1, 1 minus 1 again makes it 0. So you again get the minimum point. Here if you find it out, it's 3 minus x. So 3 minus 2, that again makes it 1. That again gets 0. Again you will get 1. So what I understand here is I get these points, and since all of these are equations of line, these are the straight lines that we have here. So if I have those straight lines, this is how your graph. So I understand this, that this is nothing but a periodic function because f of x becomes periodic function here. And so if I write that f of x is my periodic function, and if I try to find out the time period here, I understand that it becomes 0, becomes 1, again becomes 0. So from minus 1 to 1, whatever the function follows, that same cycle is repeated from minus 1 to minus 3. That same cycle is repeated from 1 to 3 as well. From 3 to 5, again that same cycle repeats. So what I understand is f of x is a periodic function, and the time period of that function f of x is 2 units. So after every 2 units, you get the same point. So if you see here 0, again after 2 units you get it 0. For 1, you get that 1 becoming again after 2 units. So f of x is your periodic function which repeats itself after every 2 units. So we get f of x as a periodic function. Now let's try to solve the value of this expression, which is 2 because. So the limits go from minus 10 to 10. And we have been given this entire expression of the function that f of x is, sorry, g of x, let's say this is entirely g of x. G of x is f of x into cos pi x dx. For f of x, we now already know it is a periodic function whose time period is 2 units. So if I have that cos pi x also known. So first of all, let's Let's understand this idea. So if I try to find out this g of x, f of x into cos pi x. So if I try to find out whether this function is odd or an even function. So for this part, instead of cos pi x, if I write cos of minus pi x, because instead of g of x, if I try to find out g of minus x, that makes it f of minus x into cos of minus pi x. So we already know cos of minus pi x is nothing but cos of minus theta, and cos of minus theta is always positive. So you can just write this cos of minus pi x will also become cos of pi x. So instead of cos of minus pi x, I can just write that as cos of pi x. Now let's talk for f of minus x. So we can just see and tell that f of minus x means f of minus 1 is same as f of 1. F of minus 2, that is 1, it is same as f of 2. F of minus 3, same as f of 3. So I can just tell from this function that f of minus x is equal to f of x. So instead of f of minus x, I can just write that as f of x. So you get g of minus x is nothing but same as g of x. And when you get this g of minus x and g of x equal, you can just tell that the function given to us is an even function. And whenever you have an even function, minus a to a f of x dx, that is given by 2 times 0 to a f of x. So here in this expression, we were told that minus 10 to 10 f of x into cos pi x dx multiplied with pi square by 10. That is equal to, I can just write that as 2 pi square by 10. And instead of minus 10 to 10, you can write 0 to 10 f of x cos pi x dx. Now let's try to solve this entire expression further. So I get this 2 pi square by 10. Now here when it goes from 0 to 10, if I understand that function, we already know for 0 to 10, after every 2 units, f of x is a periodic function. So I understand from 0 to 2, then 2 to 4. So after every 2 units, you are getting that same cycle of f of x repeated. But let's talk about cos pi x also. So cos pi x, I know already that cos of x, it repeats itself after every interval of 2 pi. So after every interval of 2 pi, it's repeating itself. So the time period for cos x is 2 pi. If I have, let's say, f of x as a time period t, f of ax, if I have, it is following the time period as t upon mod of a. Right? So if I want to find out the time period for the function which is given to us here, it's cos of ix. So cos of pi x, if I want to understand what is the time period followed by this cyclic function, I understand that cos of pi x will follow the time period which was for cos x and divided by mod of pi, that is 2 pi by pi. So cos of pi x also I understand that's again a periodic function, and the time period for this function is also. So when f of x is following a periodic function with time period of 2 units, cos pi x is also following a time period of 2 units with a periodic function. I understand that entire g of x which was there, that was f of x into cos of pi x. This entire function is also a periodic function, and the time period for that entire g of x is also. So when I have that entire expression given to me, I know from 0 to 10 the time period is 2 units. So I can write this, that as 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. All of them will follow the same idea. So I can write this entire expression as 2 pi square by 10 into 5 times. The limits go from 0 to 2, because whatever is followed from 0 to 2 is the same thing followed from the intervals with 2 units later. f of x cos pi x x. So this is your new value of the expression that you need to find out. Here if I see, I can cancel out 2 and 5 with this 10. So you are left with a new value of integral, and that becomes integral of pi square. You're now just finding the value of the limits from 0 to 2 f of x cos pi x dx. Now I know that pi square, since it is a greatest integer function from 0 to 1, there is another idea followed. So I can just split it as f of x cos pi x dx, and pi square. From the integral values from 1 to 2, you have f of x cos pi x. So this becomes your integral values. Now let's substitute from 0 to 1. We have here, from 0 to 1, we have your f of x as 1 minus x. From 1 to 2, you have your f of x as x minus 1. So if I just substitute that value of the limits here, I becomes 0 to 1. And instead of f of x, I can just substitute as 1 minus x. So it becomes 1 minus x into cos pi x dx. And the other value is from 1 to 2, you have that as x minus 1 dx. So you just need to solve these ideas. Now let's understand how do we solve this. So now if we try to solve this integral further, we know it is sum of the two integrals. So let's take these two integrals separately. Let's say this is I1 and this is I2. So if I try to find I1 first, I1 I already know its limits from 1 minus x and cos pi x dx. So if I just substitute here 1 minus x as t, I get this, that x becomes 1 minus t. So I understand if I take the derivative x minus dt, and the limits of x and t change from 0 to 1. So if I put 0 here, 1 minus 0, t becomes 1, 1 minus 1, t becomes 0. So your values of integrals I will change from 1 to 0 instead. Instead of 1 minus x, you write that as t. This becomes cos of pi minus pi t. So this becomes, and not dt, dx is minus dt, so you write minus. So you get from 1 to 0 t cos of 180 minus theta. We know it is 180 minus theta means pi minus theta. It is in second quadrant, and in second quadrant sign is positive. So cos is not positive, so it's still negative. So you get that as t into minus cos of pi t and minus that. So minus into minus turns it plus. So you get those limits from 1 to 0 t and cos pi t dt. So you have this entire expression cos of pi t, and if I just change my limits from 0 to 1, instead of 1 to 0, it becomes minus. And instead of x I t, I can just change the variable with the laws of integration. So that makes it x cos pi x dx. So that is the whole idea it becomes. Now let's try to find I2 as well from this equation. So we'll keep I1 as it is, like this. Now if I try to solve I2 also, I2 it's given to me. Again, the limits are from 1 to 2 and x minus 1. And it is cos of pi x dx. So again, if I put x minus 1 as t, I get x is equal to 1 plus t here. So I'm putting just x minus 1 as t here. So dx becomes equal to dt. And now if I put the values of x and to find t, it goes from 1 to 2. So 1 minus 1, it becomes 0, and 2 minus 1, it becomes 1. So the new values of the integral become the limits from 0 to 1. X minus 1 is t, and cos of pi x is cos of pi. X is 1 plus t, so cos of pi plus pi t. Again 0 to 1 t cos of 180 plus theta, it is in third quadrant. Cos remains cos, and because it's in third quadrant, it's negative also, so it will be minus cos of 80. Now with the laws of integration, again I can just change my variables from t to x. So it becomes x minus sine and cos of ix. So you again have this expression also in the same terms as the previous. So I understand that I1 which was there is same. So it is minus 0 to 1 x cos pi x dx. This is also minus 0 to 1 x cos pi x. So both of them becomes minus, both of them are same idea, so it becomes minus 2 times 0 to 1 x cos pi x. Now this is the entire value of I. But if I understand it was with this pi square, so we missed that pi square. So I should multiply that pi square throughout. So if I am writing that pi square here, it makes it minus 2 pi square. So we just need to figure out the value of integration and then multiply this with minus 2 pi square. So let's take this value of integral from 0 to 1 x cos pi x dx as another integral. It's I3. So I3, that makes it 0 to 1 x cos pi x. Now here if I just solve this expression by integration by parts, I know LIATE. So algebraic is U and trigonometric is V. This is U function, this is V function. We know what we do here is we take x integral from 0 to 1 cos pi x dx minus we take derivative of x and integrate again cos pi x. This is with a big. So you get this x integral of cos pi x becomes sin pi x upon pi. The limits of these values minus integral derivative of x is 1. So integral of cos pi x is sin pi x upon pi. The limits go from 0 to 1. So you have this here. If I put that x being 1 becomes sin pi by pi. So if I put 1 by pi out, x into sin pi x, so 1 into sin pi minus 0. Here you put 1 by pi out. Integral of sin pi x is again minus cos pi x upon pi. Again the limits go from 0 to 1. So you get this idea becoming, let's see. Sin pi we already know it is also 0, so it makes it 0 anyways. Minus into minus makes it plus 1 by pi square. And this if I substitute, I have cos pi x. So cos pi minus cos. So you get from here 1 by pi square. Cos pi is minus 1, cos 0 is 1, so minus 1, so minus 2. So you have this I3 as minus 2 by pi square. And we already knew that I, which I have to find out, it is nothing but minus 2 pi square into the value of I3 we just figured out, that is minus 2 by pi square. Pi square gets cancelled, minus 2 into minus 2 plus. So that was the value which was asked to us to find out. The value of this entire expression, pi square by 10, integral from minus 10 to 10, f of x cos pi x dx, and that entire value turns out to be plus. So this was how do we solve this type of question. I hope you have understood how to solve this type of questions which deals with the greatest integer function. This was a difficult question, so we took it from the very basics of understanding the greatest integer function. understanding even and odd functions, trying to find out the values of f of x, then understanding f of x being a periodic function with a time period of 2 units. Then we figured out g of x was f of x into cos pi x. We also proved that it is an even function. Then we understood I can write that entire value as 2 times the limits changing from 0 to a. So I wrote it as 0 to 10. Then we again understood cos pi x being a periodic function that makes the entire g of x also a periodic function with a time period of 2 units. Once we got that, we just multiplied the entire integral by 5, taking the limits from 0 to 10. So once we got that, we just had the limits from 0 to 2, and we separated it as 0 to 1 and 1 to 2 because of the gradation of function. And then we solved the two integrals separately and got the answer for that function. So that was how we solved this idea. I'll see you again tomorrow with some other question from some other topic. Do subscribe to my channel. Also do share these videos with your friends who are also involved in this preparation of JEE Advanced. And also try to solve this question once after seeing this video on your own. See if you are able to solve this. Thank you.